Alright guys, we're back for the second half of your lecture on the virtual day. We're going to be starting with number 24, which is looking at reducing water pollutions and preventing it, and then talking about sewage a little bit. So number 24 talks about reducing water pollution from non-point sources. We talked about how non-point pollution is so hard to clean up. So let's look at how you would reduce that. So in terms of agriculture, think about what we talked about with erosion. Think about all those ways that we learned about alley cropping and terracing and contour planting, etc., etc. So think about that. We reduce erosion. We reduce turbidity, which is a type of water pollution. Reducing amount of fertilizers or using fertilizers that release slowly. Don't use the fertilizers on land that's super sloped or steep. Planting buffer zones that can soak in excess. In Unit 4, we talked about organic farming. We talked about IPM and pesticides. And then you can also look at the legal side of it, instituting tougher pollution regulations for livestock and whatnot. Okay, and so you see some contour planting right there, and you see some buffer zones planted to soak stuff up. So that was number 24. So now let's do some more laws. My favorite. Just kidding. But these are ones you should know. Like there's like 5 or 6 in my head I know, and these are definitely some of them. So in 1972, we had the Clean Water Act. Now this was pre-Safe Drinking Water Act because it was more than just drinking water. Okay, so we're looking at 100 key water pollutants. By the way, this was a success, I would say. It requires permits for companies or polluters to discharge waste. They have to get permits in order to do that. So the result was that almost everybody is served by public drinking water that meets standards. In 1987, we had this strengthening, this Water Quality Act, which strengthened it and added more regulations. And again, if you think about who was president during these times, it wasn't partisan. It wasn't one party pushed all this and the other party didn't. Okay, we have bipartisan sponsorship of environmental laws. Keep that in mind. A failure goes back to that non-point source pollution. Because it's hard to prevent, it's hard to hold people accountable, you don't know where it's coming from, and it's hard to clean up. So what if you aren't serviced by a central sewage treatment plant, and you kind of just have to have your own? So like my husband's parents live in northern Wisconsin. They have their own septic tank. So let's talk about septic tank system, number 26. If you're looking at the United States, you're looking at about 1/4 of all U.S. houses, which is relatively significant. My guess is that you know somebody that has a septic tank. So 26 says, what is it and how does it work? So basically you have this sewage just from the individual house that's let off in this large drainage field. Okay, so I'm going to cross out the stuff you don't have to label for number 27. What? There we go. Why isn't it working? Pen. Uh-oh, the kids are coming. It's gonna be loud. You don't really need the manhole cover either. Hi, children. Okay, so the basic idea is that you have this sewage and wastewater that's pumped into a large settling tank. Hey, buddy, I'm recording. Can you not? Okay, so you have this settling tank. Some of it just happens on its own. You have this sludge that goes to the bottom. It's just more dense. So the solids fall to the bottom and are decomposed. And by solids, I feel like you maybe know what I'm talking about. Like maybe those solids come from the toilet. You've got grease and oil. Think about like oil from your skin as you shower, or like oil from cooking that rises to the top. You've got some gas that's created as decomposition happens. And then in the middle, right here, you've got this wastewater that's pumped into this drainage field. Okay, so you've got this drainage field then. It's pumped through these pipes that have these holes in it. The small holes in the perforated pipes are embedded in this gravel just below the solid surface. Like you shouldn't be able to see it. The only thing you should really see is this vent pipe to vent out the gases as the decomposition happens. So the soil filters, the bacteria decompose, and ultimately this water gets returned to the groundwater. Like it's kind of a cool system. You would have to get your septic tank pumped to get that sludge out periodically. Like how often, Dan? A couple times a year?
No.
Less than that. Okay, less than that. And then there's some rules. You can't use antibiotic soaps because it's going to kill the bacteria that decompose. You can't throw bleach or drain cleaners down there. You have to be careful of like type of toilet paper and all that stuff too. So it's rather ingenious if you think about it. So that should have answered 26 and 27. Now for the rest of us that live in an area where sewage is treated in a wastewater treatment facility, here's what happens. I talked about it with one of the classes yesterday. So you have primary, secondary, tertiary. Remember, primary means first. Primary starts with P. Physical starts with P. So the first thing that comes in, picture like all this sewer water from drains, from bathrooms, from sinks, from showers, from anywhere that there would be wastewater comes in, and they have these like, it's like a colander. They have these screens that remove whatever's floating, like these big particles, and allow the sand and the rock to settle out. Okay, then they just kind of like sit in a tank, almost like a septic tank, where the suspended solids settle down as the sludge. Now Milwaukee takes that sludge and makes it into Milorganite fertilizer. You can buy it at Stein's. Secondary sewage treatment then is biological. So now we let the bacteria go at it. We provide oxygen. Like if you drive past the one that's in Brookfield, you'll see like bubbling tanks. They provide oxygen and the bacteria help decompose the organic matter. And then the last treatment is the chemical treatment, tertiary. So we have physical and then biological and then chemical. And so that's where you would bleach or chlorinate water. You've heard of water having chlorine. Chlorine kills chemicals. So, I'm sorry, chlorine is a chemical. Chlorine kills microbes. So we can write chemical for the third one. So primary, physical, secondary, biological, tertiary, chemical. Sometimes they'll also like flash it with UV light. We don't have that kind by us, but I've read about it as well. And so again, if you're looking at it, you have this screen that filters out chunks. Then you have the grit chamber. Then it settles out as sludge. And a lot of times, like right here, it says it's disposed of in a landfill or applied to cropland. You have this aeration tank where you provide air and bacteria. You have breakdown here, and then you have the disinfection. And then it just goes back, like I said, ours goes to the Fox River. So how can we improve on this? How can we improve on this? This is number 29. One problem is not all the waste can be treated. So there's 3 of them here. So removing toxic waste before the water goes to like the city. Now this would be on businesses and industries. This isn't like a you or me thing. This is a business or industry thing so that the city water treatment facility isn't so overrun by it. Another one is just reducing. So we talk about prevention versus cleanup. Reduce it on the front end. Use something else. Again, this is an industry thing. And then kind of an out there one is composting toilets. So this is taking, well, it's exactly what it sounds like. It's composting with human waste. So you're looking at, oftentimes you poop in a bucket of sawdust, and you have these composting toilets that turn human waste into this nutrient-rich soil like humus, and then you can use it as a fertilizer supplement. The author of the book, if you read the book, has one. If you ask Mr. Wolf, he has lots of stories about the teacher that worked here before me, that had like the classroom before me, and how she had one too. How about preventing or reducing water pollution in general? So number 30, I think it says list 4 ways. Which ones do I like? Let's see. I like reduce non-point runoff. It's super hard to clean up. Prevent water contamination. Work with nature to treat sewage, and find substitutes. We're going to talk more about the 4 R's later on. I don't like reduce poverty, slow population growth. Like that seems just like such a big task. It's not as simple as that. And so then if you break it down to the individual level and you look at what you can do, that's the last question. Pick 3 things. We use compost in our gardens. That might not be an option for you. Maybe it is. Minimizing pesticides. Clearing off, like if you have storm drains in the road so that like leaves and stuff don't go in there because they end up in the wastewater treatment facilities. Not using water fresheners in toilets. Okay, those are chemicals that end up in there that are hard to treat. This is a big one. Don't flush your medication. What should you do with it? Oftentimes, because you shouldn't throw it away either, oftentimes they'll have collections for like unused medication. And then don't pour stuff that shouldn't be poured. I can't even tell you the number of times I've done a lab and I'm like, can I pour this down the drain? Can I not? And usually I have to go ask Mr. Harder and then he knows. So write down 3 things that are practical for you or your family. So that's it for water pollution. We will finish with the few questions that we missed about oil spills, which is 20, 21, 22, 23. There's just 4 questions and a few slides left. We'll do that before the oil spill lab. Have a lovely rest of your day.